All right, everyone. Any questions before the last piece here on collections and strings? Awesome. Okay, cool. So, last part here. I had planned on having a little more time for this than I do, so I'm going to have to blast through some stuff. Don't worry too much about it. You'll be running into this stuff all the time, and they are all included in the readings as well, and the readings go into more detail than I do anyway. So, I'm just giving you the highlights. The readings are where you're going to do the learning. Optionals. Apologies, 1 second. Let me verify something. That's not... I thought that we looked at nil first. 1 second. Oh, we do. Okay, cool. Sorry. Had one of those, my dad would call it a senior moment. And he would call it that because he's 75. So, I don't have that excuse. I'm not 75. All right, so optionals. What are optionals? We'll look at that. Before we ask what are optionals, though, we're going to ask what is nil. Okay? Nil is something that is specific to Swift. I haven't seen other languages that use nil specifically. They use something called null. All right? So it is very similar to, but not exactly the same as, null in other languages. Languages like Java, C, C++, C Sharp. I think Python has some form of null, but it might be nil also. I can't remember. And JavaScript as well. So it is a keyword that you can type that indicates a valueless variable or constant state. So basically, when you say assign nil to something, you're saying this variable is empty. There's nothing here. It doesn't point to any place in memory. Its memory value is 0x0, right? It doesn't go anywhere. By default, in Swift, variables and constants cannot be assigned nil. You cannot assign nil to them by default. And we'll talk about why when we talk about optionals. But this is just very important for you to know because it is the opposite of how it works in literally every other language that I saw on the list of languages that everyone knew in the assessment. If you know another language that does this by default, do let me know. I'd love to learn it because it's my favorite feature of Swift. And that is that only optional variables and constants can be nil. So as I said, by default, normal variables and constants cannot be nil, and things called optional variables and constants can be nil. And that is the main distinguishing concept between an optional variable or constant and a regular variable or constant. So let's talk about optional. Optional is a wrapper that is placed around a particular type. And later on, when we talk about enums, I will show you how the optional type is implemented using enums in Swift. But for now, all you need to know is that it is a wrapper that you can place around every single type in Swift, including the types that you create. So if you create your own class or enum or a function type, you can wrap it with an optional indicator. And then it becomes an optional type. If a variable or constant has a type that is optional, and the way that we just say that in short is we just say it is optional, then it has the ability to be nil. By default, that's not the case, as we said. When you are using optional types, if you are trying to use them with non-optional types, aka regular types, aka just the default type provided by the language, like int or double, you can't. Not by default. You have to do something specific. But they are not compatible. You can't add them. You can't compare them with less than or equal to, etc. In order to do that, you have to do something called unwrapping the optional. and turning it into a non-optional. So Swift provides tons of syntax surrounding optionals specifically because it is a huge part of the language to be able to use and reason about optionals, because Swift made a choice about language composition that no other modern language has done. I think there's some, like, I think Haskell does this also, but like no one uses Haskell. So, you know, whereas Swift gets used by most every iOS developer on the planet. Okay? So there's tons of syntax for optionals. I will show you some of it here today. I will not show you all of it. The readings cover a lot of it, but not even all of it. So, you know. And then I mentioned this before, but by default, it bears repeating for like a fifth time. All types in Swift are not optional. You cannot assign nil to them. You will get a compiler error if you try to assign nil to them. Okay, so let's look at it. Optional types. So, if we define a constant myOptional int, and we declare that its type is int with a question mark, we are saying, hey, I want this to be an optional of int. I want this to be an int that could also be nil. That's basically what you're saying with that question mark right after the type, okay? Question mark is primarily the character that we use when interacting with optionals. There's also exclamation mark that does forcing stuff. I'm not going to cover that in the lecture. That is in the reading for this week, but it is best practice not to use that, so that's why I'm not covering it in the lecture. So this is our optional type, int question mark. Cool. So let's say that we have a new variable called myInt, and it has type int, and we try to assign myOptional int to it. This should be pretty straightforward. However, the compiler gives us this error. Value of optional type int question mark must be unwrapped to a value of type int. Because int cannot have nil assigned to it, but myOptional int can have nil assigned to it, and in fact, in this case does. But just because it could have nil, we have to do something in the case that it is nil. We have to say, oh, okay, so if we want to take the value, the int value that's in the myOptional int variable, and assign it to something that should be just an int type, we have to do something if that's nil, right? In the case that that is nil, we do something else, okay? There's many ways to do this. We're going to cover them. The first one is called the nil coalescing operator, okay? This will make your error go away. You'll note the two question marks. Question marks are the character we most frequently use for interacting with optionals. So basically what we're doing here is we are unwrapping the myOptional int in a safe way. We are saying, hey, if myOptional int, the variable, the constant, has in it a nil, it has in it no value. It is set to nil. It doesn't point anywhere. Then, in that case, whatever is to the right of the nil coalescing operator is what we assign. So if myOptional int is nil, my int gets 0 assigned to it. If myOptional int is not nil, then it assigns whatever int value myOptional int has to my int. If you wanted, you could consider this to be an expression that evaluates to the type that the optional wraps around. That's one way of thinking about it. But you can also just think about it as kind of like saying, like, it's almost like a ternary operator, really, if you think about it, where you're putting on the left-hand side of the question mark, myOptional int equals nil, question mark, myOptional int not equals nil, question mark, myOptional int, colon 0, right? It's basically that, but made smaller. So another way to unwrap an optional is to use if-let. If-let is basically a way of saying, hey, I want to create a constant that can be used within my if block scope moving forward, and I know that it is not optional. I know that it can't be nil. I know that it is safe, and I know that I don't have to worry about a null reference error when I'm using this constant, okay? So if let is a very special kind of if block where you basically define a constant, in this case my int, you attempt to assign to it an optional of some type, and then within that if let block, so within the scope of it, that constant you defined, my int, is of the type that the optional was wrapping around. So in this case, int, right? So my optional int is an optional wrapping around int, and my int is just an int, okay? Of note, if let specifically limits the constant's scope to the brackets defined by to the scope defined by the if statement. So it's only within those brackets that my int exists. After those brackets, it falls out of scope, it gets released from memory. It doesn't exist anymore, okay? Cool. So let's say you have a huge block of code, right? And you're doing a ton of stuff in it, and you need to use you need to unwrap an optional, and you're going to use it a lot in that code, right? You could put it all inside of this if let block, but let's say you need to do that 3 or 4 times. Let's say you have 3 or 4 optionals that you need to unwrap all at once before you do anything, right? At that point, you're going to have nested if-lets, where it's like if-let, 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 right, with indents on them, and then your code's going to be this tiny little thing all on the right side of the screen. It's just gross and nasty, and no one likes that, right? Swift has a cool way to allow you to basically handle this particular case, which is called guard-let. Guard-let is kind of the opposite of if-let. It's basically saying, hey, if we can assign my optional int to my int, and it wasn't optional, right? And my int is now an int type and could never be nil, then outside of my scope, we have created a constant out here, moving forward after that scope falls out, where my int's type is int, and we can refer to it and use it. And then within the block, we do what's called escape. So you can break if you're inside of a for loop. You can return if you're inside of a function, that sort of thing, right? But whatever it is, it has to guarantee eventually, like you can do a bunch of code within there, but at the very end, the last thing you have to do is leave whatever your outer scope was. And then it applies that keyword to the outer scope, whatever that was. So again, if it's a for loop, break will leave the for loop. If it's a function, return will leave the function. Of course, return also needs to include a type if you have a particular return type declared for that function, but that's a different thing. Another thing that you can do to exit the function early is throw, which we're going to talk about very shortly. So yeah, basically within guard, you have to leave fast. You have to get out. You have to guarantee that if you enter the guard, you don't ever fall out of that scope to the one outside. The outside scope needs to be exited before you leave the inner scope. And we'll see a lot of examples of that later on, not this slide, but like later on throughout the class, which might make it a little easier to understand. Okay. So, what was I thinking? We mentioned this before. So we've seen this function previously. This is a closure that we are assigning to a constant that has a function type set for its type. Then we call it, and we perform some multiplication. Please note this is relevant to your assignment for this week, okay? So, I'd mentioned that this code actually creates an error in Xcode. And not to worry about it, because we're going to get to it later today. We're getting to it now. So the thing about the way Swift is when you are casting from a string, which is what we're getting passed in here, to a double, Swift can't guarantee that will work. The string could contain an alpha character, so it could have B or X or C or something in it. It could have a special character like a plus or something like that, right? Basically, it can't guarantee when you pass it in that the string is just a number, right? There's no way to say that with a string type, okay? So, that said, double does provide an initializer that allows you to pass it a string, and it does its best to try and take that string and turn it into a double. If it can't turn it into a double, it returns nil, which means that double.init passing in a string returns an optional double type. So, this line creates an error. This line creates an error because we attempt to multiply two optional doubles together and return the result of that as a non-optional double. Because the return type of our closure, as defined up in multiplication's type definition, is double. But these are, not double. They are optional double. So, to make that error go away, we can unwrap whatever is returned from these initializers. In this case, we use the nil coalescing operator to switch it to 0. Is that the correct result? Is that what you would expect to happen? I don't know. It's up to you. You're writing this multiplication function, not me. But basically, you can kind of handle this in a number of different ways. But the point is that you need to be able to handle the fact that you could get nil back. So here we're making a choice. This is a design choice. It is the wrong design choice. I will give you that hint. So, the other thing you can do with optionals is something called chaining. Here we define an integer array that is an optional. So it's an optional array. Here we want to call the sorted function to get a copy of the array that is sorted. However, it is an optional array. So the compiler doesn't know what to do because the optional array doesn't have a .sorted function on it, right? That type, optional type, doesn't have sorted, right? Array type does, but optional array doesn't. So it's like, hey, you have to do something about this. You have to unwrap this. You have to tell us, hey, to do something, right? So you could use nil coalescing, and you could unwrap it and pass it into another constant and then call .sorted on that constant and then pass that. That's a little cumbersome. It's a little unwieldy. There's something else you can do instead. Instead, you can do optional chaining. And optional chaining is when you just say, pass the buck, I don't care, okay? Basically, you say, yeah, I know that this variable or constant is optional, that it could be nil. If it is nil, then just assign nil to the sorted constant. I don't care, right? If it isn't nil, then call my function, okay? And you can chain this. It's called optional chaining because you can keep doing it over and over and over again. Like if you're calling multiple functions on functions on functions and they're returning optional types, you can keep doing question mark. And it's basically saying, if this thing is nil, just don't call this function. Just return nil. I don't care, right? So it's a lot of logic, a lot of if statements or ternary operators that you can just kind of put into a single character. And it operates in a pretty intuitive way. But of course, this means that our sorted constant is now a optional int array as well because it could be nil. It's not a non-optional int array. It's not a regular int array. Another thing you can do specifically with arrays is for optional chaining. You can use optional chaining for accessing things by index, okay? So a lot of arrays, they'll have, arrays or collections, they have this, open bracket, close bracket style that we talked about. You can basically use the question mark right in front of it just like you would with any function call, okay? Cool. So the other thing that you can do, let's say that you want to iterate over a optional array, all right? You need to safely unwrap it, okay? So what you can do is say, hey, inline here, right? We're just going to say after the in, we know that we have to have an expression that evaluates to some sort of collection that we iterate through. So we're going to say amounts with the nil coalescing operator and then empty array. What this is saying is if amounts is nil, then we use an empty array, and when you're iterating over an empty array, you literally just do nothing. It's a no-op. So if amounts is nil, don't do anything, otherwise iterate through it and print the amount. Okay, that was optionals. I covered optionals very lightly due to time and a number of other reasons, but they are important. They will come up all the time for you in Swift. They will be annoying and aggravating, especially if you're used to other languages where nil can just exist and float around and cause null reference errors all over the place, right? Swift uses optionals in the way it does specifically to force you to deal with any problems that happen from referencing types that are nil at compile time rather than at runtime. The earlier you can catch an error, the cheaper it is to fix the error, which is why it takes less time, right? Which is why Swift does this. But when you're first starting out, it can take a while to get used to it. So anyway, so that's optionals. Now we'll talk about error handling. We're on pace, cool. All right, so in theory, error handling. Functions and closures, which we talked about earlier, can throw errors. Basically, they can exit early, as we said, in a way where they say, hey, something went wrong. I'm not giving you my return type. I'm not doing anything. I'm leaving. I'm getting out of Dodge. We're leaving scope. It's done, right? And that's called throwing an error, okay? If a function throws errors, if it has the capacity to throw errors, then you have to handle it by when you call that function. Any function, anytime you call a function that could throw, you need to handle that, all right? This is Swift being very, very strict about this. Some languages that have throwing say, yeah, you can catch the errors if you want, but we'll let you compile if you do nothing anyway, right? Which is, means that no one ever does anything. No one ever handles the errors unless they absolutely have to. Swift forces you to do it at a compiler level. Once again, making sure that you catch errors earlier in the development process, literally in this case. So you handle errors in multiple ways. You can use a do, try, catch statement block. You can use error propagation, or you can convert it to optional and deal with it that way, if you're more comfortable with optionals. So let's look at throwing errors. This is an enum. This is how you define errors that you can throw. We haven't talked about enums yet. That's next class. For now, just know that this is the syntax for defining errors. You use the enum keyword. You define like a name for your error kind, like the kind of error, the category of error. By convention, it tends to have the word error at the end. You do this colon thing. You put the error word after that. And then you do this thing where you say case, and then you have your specific kind of error here, okay? We'll talk more about that next class. It'll be a lot clearer there, but for now, this is just how you do it. If you need multiple cases, if you need to have different kinds of errors within one category, you just do a new line, and then you do case, and then the name for the new type of error. By convention, cases are also lowercase at the start, and enums are capital case at the start. Okay, so that's our error. Then we define a function here. Let's go ahead and call it divide. And it has a left-hand side, which is a double, and a right-hand side, which is double. Those are the parameters that get passed in. We have a double return type, and also this thing called throws. Throws always happens to the left of our arrow and to the right of our parameters. That is where it goes. That's where you put it. It's basically just a special keyword that says, hey, by the way, this function throws an error. So with division, you want to handle the fact that some person might try to divide by 0, which can cause problems for a computer. It doesn't know what to do. It gets mad. It gets upset. It might crash the program. You don't know. It depends. I need to log in to NU Wave Guest, which is weird because I'm tethered to my phone. I'm not sure why it's decided to do this now, but I'm getting rid of it. Okay. So if someone were to pass in 0 as the divisor, or the bottom part of the division, so these dividend divisor, is that how it goes? I don't remember. It's been too long since I did basic arithmetic. I know quotient is the answer, but So if we divide by 0, right, then if we try to divide by 0, then we don't want to actually perform the division because the compiler can be upset by that, right? We want to basically instead inform whoever called us, hey man, you messed up. You tried to give me a 0 in my right-hand side, in my divisor, right? That's not allowed in division. Don't do that, right? So we throw calculator error dot divide by 0, which we defined up here in our enum, okay? And that's just the format for how you say, hey, here's my error that I'm throwing, okay? So we throw that. We basically say, yeah, okay, whoop, exit, right? This is basically the same as doing a return, okay? We leave the function scope. We don't do anything else, right? Anything that comes after this doesn't happen if we hit throw, right? Same as return. And then here we return left-hand side divided by right-hand side because we can just do that because we feel safe, right? So basically, we just don't have to worry about it because we know that because we threw, we left the function, we're not continuing to execute the function lines, and we'll never hit the return. Okay. So let's go ahead and collapse this just to, it's all the same on the inside. We're just making it smaller so that we can see everything. Let's go ahead and call this function and see how we handle that. Okay. So when you call a function that can throw, you need to handle that. If you don't, you'll get a compiler error. I thought I had a piece where I showed the compiler error, but I don't. So don't worry about it. But basically, if you ever try and call a function that throws, it will say, hey, this function can throw and you're not handling it. Then you need to do one of these things. So one of the things you can do is do try catch. All right. So basically, you create this kind of structure where you create a do block of code. And within that scope, you call the function that can throw. And then before you call the function that can throw, you use the try keyword. When you do that, then basically that block, if that function doesn't throw, you just continue executing everything in the do block, right? But if at any point in time, anything in the do block, anything that you try calling that could throw, if anything there does throw, then you immediately exit the do block and go to the catch block instead. And then you execute code there. So in the catch block, you can access the error that was passed to you in a number of ways. This is one of them. You can say catch let error, which creates an error constant. This just holds the value that we threw, which is calculator error dot divide by 0. And then you can do things like print it or do something different or extract an associated value or whatever. But basically, this code will now compile. Whereas if you had just done let quotient equals divide without a try or anything, it wouldn't compile because you're not handling the fact that it could throw. So here we are basically we are catching a very specific error. So with a do try catch block, you can catch many different kinds of errors, sort of like when you do a switch statement, you can have multiple different cases. You can just chain them together. So you can catch calculator error dot divide by 0. Then after that, in the same way that you kind of start this catch right after this block ends, right after this catch block ends, you could put another catch for another kind of error that you want to catch, right? Swift will yell at you for this code technically because you're not handling all potential error cases, right, as it puts it. You do need to, by the end, at least catch all general errors, which is done by this. So just be aware of that. And then the other thing you can do is propagate the error. Okay. No. Wait, where are we? What are you? Okay. Well, that was weird. I guess I'm not going to be doing this with slides. I'll just do this in here because I think some of my animations got chained together in a way that I did not intend. Yeah. Okay. So, and if I just go to animate, yeah, there we go. All right, now I can do this. Move this here. Maximize this. Okay. So, here, we have moved our try into a new function. Let's say you're in some function and you call another function that throws, right? If you don't want to handle it, if you want to continue to pass the buck further and further up to previous callers and not handle the problem yourself, you just mark your own function as throw. And then whoever calls that function has to deal with it. It's up to them, right? So then we see here further on, later on, we have to do the do, try, catch, let error block around our new function arithmetic, which now also throws because we are just propagating the error forward, okay? And then now this is going to try and quit on me again, I think. Yep. So this one also, yeah, it's because I duplicated the slides. Here we go. Boop, boop, boop. Okay. The other thing that you can do is convert the error to an optional. So rather than catching it with the do, try, catch block, right? Rather than handling it in that way, instead, if you put a question mark next to your try, then what happens then is when you call that function, if the function throws an error, it returns a nil version of that function's return type. So in this case, an optional version of that function's return type. So in this case, divide returns a double by default. But because it throws, we have to handle any errors it throws. So we can choose to call try question mark to, when we call the function, we can use try question mark to say, hey, if this function throws, I don't really care about the error, just return an optional double, right? This is a very easy way to handle this problem, especially if a function can throw a lot of different cases, and at the end of the day, all you care about is did I or did I not get my return type, right? If you don't care about all the different error cases and you don't have to deal with all of them, and you just want to know, hey, did I get it or not, right? Then you can use try question mark, and then you get a nil value put into your variable or constant if there was an error, and then after that you can check to see if that variable or constant is nil and do error handling that way instead. That is kind of a way of masking and erasing the whole error process, but sometimes it is appropriate. Most of the time though, eventually you'll want to have a do, try, catch block. But if you want to just kind of prevent that from happening, you can use a convert error to optional approach. Okay, that's error handling. There's more to it, but again, covered in the readings. And optionals as well. So we are now at the end of class. There's like 2 minutes left. Does anyone have questions for the class and the recording? If you don't, I'll also be here afterwards for further questions if you've got them. Cool. Okay. The assignment should be up and available. It is to create a calculator, a Swift package manager calculator that takes in an input from the user, and which I just realized I don't know if my readings include that, so I will make an update to make sure there is a reading that talks about how to pull input from the terminal. So basically, the user types in 100 plus 100, and then you print back 200, okay? So this calculator, what you're getting in is a string. It is just a string. You're going to have to use the knowledge on substrings that you will read in the readings to break that string apart into the left-hand side, the right-hand side, and the operator. You do not need to worry about advanced arithmetic functions. So things like 100 what's the one with the circles? I can't remember. Modulus. You don't have to worry about modulus. You don't have to worry about chained things. You don't have to worry about parentheses, order of operations, and anything. It's just two values and then a operator in the middle. As always, the assignment is not graded. It is not submitted. This is for you to do. It is practice for the quiz in class 3. The quiz in class 3 will be asking you questions to kind of, verify you did the assignment, right? So the assignment I would expect would take a few hours to do, so make sure you do block that time out. Try not to do it Thursday night. But it is the kind of thing that the reading will also help a lot with. So if anyone has questions about the assignment, I'm happy to answer those as well. So, and then I'm going to be here for about half an hour after class because I was late for my office hours today. So if anyone has questions that they feel would be better for office hours, I'm here for those as well. Also, IT was helping me with stuff, and that ate into the office hours too. So, cool. All right, everyone. That's it. Class 2 is done. I will see you for class 3.